We are now going to have a closer look at the connections inside a typical 200 amp service panel. The breakers are installed in a panel, so that contact is made with one, or both of the hot bus bars running down the middle of the box. The hot wire for a branch circuit is connected to the breaker by a set screw on the base. The neutral and ground wires for the circuit are connected to a bar along the side of the service panel box. The neutral and grounding bars in the panel may be separate, or in the case of older service panels, the same bar may be used for both purposes. This diagram illustrates a 15 amp circuit breaker for a 120 volt branch circuit. The 14-2AWG cable for this circuit includes 2 conductors and 1 ground wire. A 15 amp circuit is usually used for wall receptacle outlets and room light fixtures. This illustrates installing a 15 amp circuit breaker for a 15 amp branch circuit to a ground fault interruptible receptacle, or GFI. The 14-2AWG cable for this circuit includes 2 conductors and 1 ground wire. This type of receptacle is usually found in bathrooms and outside wall receptacles. Notice that the black hot wire and neutral are connected to the line screws of the GFI receptacle. Additional receptacles may be connected to the load screws of the GFI, making them ground fault protected by this GFI. This arrangement is for a 20 amp, 120 volt double receptacle circuit with a shared neutral wire. This arrangement is typically used in a kitchen, where 2 separate appliance circuits are needed in close proximity to each other. Notice that the breaker is a ganged, or double pole, single throw breaker, which means that it switches, or trips both circuits at the same time. This circuit breaker wiring diagram illustrates installing a 20 amp circuit breaker for a 240 volt circuit. The 12-2 gauge cable for this circuit includes 2 conductors and 1 ground. The white wire is used as a hot in this circuit, and it is marked with black tape on both ends to identify it as such. A neutral wire is not used in this circuit. A dedicated 20 amp circuit like this is used for heavy household appliances, like large portable window air conditioners. This is an outdated circuit that may still be used in some situations. This wiring is for a 30 amp circuit breaker, serving a 30 amp, 240 volt receptacle. The 10-3 cable for this circuit has 3 conductors and no ground. A 30 amp circuit like this may be found in older installations, for example, clothes dryers, or maybe a kitchen cooking range. This illustrates a new, 30 amp circuit breaker, feeding a 30 amp dryer outlet. This is an upgrade of the outdated 30 amp circuit in the previous diagram. This breaker is connected to a 30 amp receptacle, with 10-3 cable, and a ground wire is included for protection against electrocution not provided by the older circuit. This is an installed 50 amp circuit breaker for a 240 volt circuit. The 6 gauge cable for this circuit has 3 conductors and 1 ground. A 50 amp circuit like this is used for new kitchen range installations. This diagram illustrates wiring for a circuit breaker with a built-in ground fault circuit interrupter, or GFI. This 20 amp, 120 volt breaker is a form of GFI that can be installed at the circuit source. This kind of circuit is used for dishwashers, whirlpool spas, and other locations where water contact is likely. This diagram illustrates the wiring for a circuit breaker with a built-in arc fault circuit interrupter, or AFI. This 15 amp, 120 volt breaker is a form of AFI that can be installed at the circuit source. This kind of circuit is used for receptacles designated for appliances such as microwaves. We have already seen, in a previous video, a subpanel could be the means by which standby power is supplied to a home. This slide shows an actual installation of a smart home panel 2, that has both the generator input, as well as connection to the main grid panel. You can see the circuits that need to be secure entering the panel at the top and are tied to the individual breakers inside this panel. Installers have drilled holes to connect the NMD cables for 1 to 12 load circuits. As I mentioned before, a single Delta Pro Ultra can do an impressive 7,200 watts of output, which is going to take care of most people's needs. And you can add a second or third unit here to get 21,000 watts of output. A single unit can also stack up to 5 batteries for 30 kilowatt hours of capacity. And you can do the math, 3 units can supply 90 kilowatt hours of capacity. So let's have a closer look at the connections inside the main and sub panels. More specifically, how they are connected together. In actual fact, the connection is fairly simple. A 100 amp double pole single throw breaker in the main panel is connected in parallel to a 100 amp double pole single throw breaker in the subpanel. This connection energizes the two bus bars in the subpanel. There is a connection between the neutral bars of the two panels and the connection between the two ground bars of the two panels. The wire gauges are the same as those specified for 100 amps. The standby generator subpanel does not necessarily have to be placed right next to the main panel. It could be mounted on the outside of the house, or, as in this case, mounted in the garage. The EcoFlow Delta Pro Ultra is one of the most versatile, whole home backup solutions that has just been introduced to the market. This backup power system is designed for both extended outages and daily use. With an unrivaled capacity of 6 kWh, 7,200 watts output, and 5.6 kilowatts solar input, a single unit can run your entire home. With EcoFlow Smart Home Panel, you get an uninterrupted power backup experience with automatic switchover, energy consumption monitoring, and lower electricity bills. This unit is not driven by gas or diesel generation but uses the battery storage unit that is charged when the utility is available. This means that the unit can be placed indoors or outdoors and is virtually silent when operating. It has a stackable design that can be expanded to increase output in only minutes. Compatible with various energy sources, from solar to gas, to meet your ever-changing power needs. To obtain more information on this subject, and pick up your free digital copy of the Ultimate Guide to Residential Standby Generators, simply fill out the information requested when you go to this website, https://bit.ly/3 uppercase s uppercase p 0 lowercase x uppercase v uppercase y